let's look at solving equations that are quadratic in form. Let's start with this example. This is not a quadratic equation. This is a degree 4 equation. But we'll see in a minute that this equation is, however, quadratic in form. To see that, let's take a look at the variable powers. X to the 4th and x squared. And those are the only occurrences of x. What is the relationship between these two? Well, we see that if we take x squared, we square it, we get x to the 4th. So let's write down the following quadratic equation. Let me use the letter u. I want to use a different letter. And what is the relationship between the variable powers in this equation? Well, it's similar. U squared is the front expression, u squared. So it's a similar relationship. And this will allow us to transform our original one into a quadratic equation. Let's see that. Let's let u equal x squared. So our original equation becomes, after substituting in u for x squared, it'll become u squared minus 10u plus 25 equals 0. Again, I'm just letting u be defined to be x squared here. So the substitution just gives this. And in this equation, when we solve it for u, it's quadratic factors by hand. It has a unique solution, u equals 5. So let's talk about the connection between the solutions to this equation, this quadratic equation, and the solutions to this degree 4 equation over here. Can we get the solutions to the original equation from the solutions to the quadratic equation? So here is the precise connection. To find the solutions to the original equation, we take the solutions in u to the quadratic, and then we solve the relationship. Solve for x in u equals x squared. That will give us all the possible solutions to the original equation. Let's do this here. So we had just a single solution, u equals 5. Here's our relationship between u and x. We will solve that for x. Put in 5 for u, solve for x. Take the square root both sides, and we get that x is plus or minus the square root of 5. So now we need to check in the original. Let's start with x equals the square root of 5. Is that an actual solution or an extraneous solution to the original? Let's see. The square root of 5 raised to the 4th power is 25. The square root of 5 squared is 5. Does this left-hand side equal 0? 25 minus 50 plus 25, is that equal to 0? Yes. Now let's check the other possible solution. Always remember to check whenever you're solving an equation. It turns out that this is the same as what we had in our second step below. So, yes, this is a solution too. So, this original equation has solution set like this. And this method is a good way to solve an equation like this. Let's do another example. Let's take a look at this equation. This is not a quadratic equation, but we see that the relationship between the variable powers implies that it's quadratic in form. This squared equals z to the 1/2. So let's give a name for z to the 1/4. Let's call it u. We need a different letter. So then replacing z to the 1/4 by u gives, let's see, if u equals z to the 1/4, then u squared is z to the 1/2. So we get u squared minus 4u plus 4 equals 0. Solving this equation for u, this quadratic equation, we get the single solution u equals 2. So now let's find the solutions to the original equation. So we have u equals 2. And the relationship between u and z is that u equals z to the 1/4. So let's put in 2 for u, then solve for z. Raising each side to the 4th power gives z equals 16. Remember to check. The square root of 16 is positive 4. The 4th root of 16 is positive 2. And yes, it does check. And we're finished.